Hello, in this video, I will go over all the steps of graphing an exponential function with its reflection, shift, stretch, and shrink. So, uh, what does a typical exponential parent graph look like? So there's an increasing exponential where the base is greater than one. So if you look at the example, uh, y equals 2 raised to the x, the base is greater than one. It's 2, right? And what is else? So this is what's called an increasing. And what else do we know? We know that this has a y-intercept of 0, comma 1, and then I'll talk about this later, but you do have a horizontal asymptote at y equals 0. Okay, so this is an increasing, it looks like this is what a typical increasing exponential function looks like. Okay, and then the next one is, I believe, is going to be decreasing. So this is an example of a decreasing where the base is less than 1 but greater than 0. As you can see, it's still positive. So in our example, it looks just like the increasing, but it's heading to the left. And as you can see, the base is 0.25, which is still less than 1, but still greater than 0. So most likely a fraction. Okay, so that is a decreasing. So let's talk about the characteristics of an exponential graph. So usually exponential has a y-intercept of 0, comma 1 unless there's vertical shift. And I will explain that uh, later on. If the base is greater than 1, then it's an exponential growth. So on the first slide, you saw an exponential growth. If the base is less than 1 but greater than 0, then it's an exponential decay. So it was on the second slide. So usually a decay would be when the base is like a fraction or a decimal. Rule The third one is exponential graphs do have a horizontal asymptote at y equals 0. So if you look at the previous ones, they don't show it, but you do have an invisible horizontal asymptote at y equals 0, y equals 0. So right here. Okay. And then what else do you know? If you have a vertical shift, then your new horizontal asymptote is your vertical shift. So that's very important when we graph it. If you have vertical shift, if you have a D, that is your new horizontal asymptote. Okay. Rule 4, domain is all real numbers. So all real numbers, and the range is 0 to infinity unless there is a vertical shift. Okay, so you know the characteristics of an exponential. You know what it kind of looks like. Uh, how do you graph exponential graphs? So just like the previous graphs, linear, quadratics, we wrote everything we knew about the graphs. So just like exponential, you write everything that you know about exponential graphs. For example, is any horizontal, vertical, reflection shifts, etc. Then what I would do is pick 3 coordinates from the parent graph and do the add-ons. So just like the other graphs, when you have a shifts, reflection, just pick 3 coordinates from the parent graphs and do the add-ons. And I will explain. And then if you have a vertical shift, then your vertical shift is also your new horizontal asymptote. That sounds confusing, but I will do an example. Okay, let's start with example 1. It says graph both f and g function and describe the transformation. So let's start with f of x. You have f of x equals -2 raised to the x. You have a -2. So what I'm going to do is I'm going to plot 3 points from the parent graph, +2 raised to the x, okay? So pick 3 random points. So I'm going to pick, so when I plug in 0 into this function, I'm going to get 1. So how did you get 1? So all I did was I plugged in 0 into this function 2 raised to the x, so that's 2 raised to the 0. Anything raised to the 0 is 1. I recommend doing 0 and then doing some positive and some negative x value. So the next x, I would use the x value 1. And when you plug in 1 into this, you get 2. And then I'm going to do -1 because I need a negative value, right? So if I plug in -1, I get 2 raised to the -1, which is 1/2, which you can say 0.5. Okay, so these are your parent points from the function y f of x equals 2 raised to the x. But this is our graph. So what do we do? Like the only difference is there's a minus, right? So if you have a minus in front of the base, from the previous graph, all you do is multiply the y value by -1. So you start with these coordinates, right? And then all you do is multiply the y value by -1. So 0, 1 will now be 0, -1. 1, 2 will be 1, -2. And then -1, 0.5 will be -1, -0.5. And that's it. Would be this graph. So if you want, you can plot it. So on this graph, do we have a horizontal asymptote? I mean, do we have a vertical shift? No, we do not have a vertical shift. So that means that our horizontal asymptote is at y equals 0. So if you want to graph that, that's fine. So I do like a little dashed line like this. And then plot these 3 points. So 0, -1 is right here. What else? 1, -2 is here. And then -1, -0.5 is right here. Okay. And then if you connect those dots, it's going to look like this. Okay. So that is the first one. And then let's do the next one. This is g of x equals 5 minus 2x. Honestly, I'm just going to rewrite this. This is equivalent to saying they're just trying to confuse you. This is equivalent to saying -2 raised to the x plus 5. That's much better. So this is the same as this. I don't know if you could see that, but that's what I saw. And then what is the difference between, what's the main difference between this and that? What is the add, like, what are they adding? They're basically adding this 5, right? And what does that 5 mean? It means you have a vertical shift 5 units up, right? So what that means is you can use these points, 0, -1, 1, -2, because it came from here, right? This points came from this graph. So then all we got to do is add 5. So all you got to do is add 5 on the y value. So starting with 0, -1, it would be 0, so you add 5 on the y value. So 5 plus -1 is 4. 1, -2 will be 1, 3. And -1, -0.5 will be -1, 4.5. Okay. So if I plot that, 0, 4 would be right here. 1, 3. And -1, 4.5. What else do we know about this graph? If they say that if we have a vertical shift, it's also your new horizontal asymptote. So we have a vertical shift at 5, so our horizontal asymptote is at y equals 5. You can draw that dashed line right here. So this says y equals 5. And then if you connect the 3 dots, it should look something like this. There you go. There's your graph. Go ahead and copy. Yeah. So yeah, that's pretty much how you graph this. Pick 3 points from the parent graph and then just do the add-ons. Okay, I'm going to move on. So if you need to rewrite it, just go ahead and press pause the video. Let's do example 2. Graph both f and g to describe the transformation. Okay, so this is fine. It's not too bad. So what do we know about this graph? It is a growth. It doesn't have a vertical asymptote. It doesn't have a vertical shift. So we know that the horizontal asymptote is at y equals 0. And what else? Yeah, so let's just pick 3 random points. So I'm going to plug in 0. I always plug in 0. So 3 raised to the 0 is 1. So your first coordinate would be at 0, 1. And then I'm going to plug in, let's just do positive 1. So when you plug in positive 1, you get 3. And then let's use a negative value. So let's use negative 3. Negative 3 would be 1/3. Yeah, 1/3. Wait, 1/3 is, it's like 0.3. Okay, so go ahead and I guess you can draw your asymptote. Y equals 0 right here. And then plot 0, 1. So 0, 1 is right there. 1, 3 is right there. Negative 1, 0.3, that is right about here. Okay, connect the dots. And this is your graph. Y or f of x equals to 3 raised to the x. Okay, now let's do this one. So what's the difference? They have this x minus 4. So what does that represent? It represents a horizontal shift of 4 units to the right. That's it. We don't have a vertical shift, so that means our horizontal asymptote is still at y equals 0. And we still know the base is 3, so we know it is a growth. Okay. So we're gonna start with these previous points, and then because all we have is a horizontal shift of 4 units to the right, what that means is you're just gonna add 4 to the x value. So starting with 0, 1, it will now become 4, 1, because all you did was add 4 to the x value. 1, 3 would be 4 plus 1 would be 5, 3. And then negative 1, 0.3, that would be 4 plus negative 1 is 3, 0.3. There you go. That's it. And then plot it. 4, 1 is right here. 5, 3 is right right there. 3 comma 0.3 would be right about there. And still have an asymptote at y equals 0, so it's still a dashed line like that. Connect the dots. And there's your graph. Go ahead and pause. Should we do? I think I'll just finish everything in one video. So let's move on to example 3. So example 3 says graph the function and this time determine the domain and range. So last time we didn't figure out the domain and range. So, okay, so let's start with this one. So what do we know about this graph? We know it is, the base is 1/2, so it's less than 1 but greater than 0, so we know it is decreasing. And what else do we know? We also know that this is a horizontal asymptote at y equals 0. And let's just pick 3 points from this graph. I'm going to just plug in 0. I always do that. So 1/2 raised to the 0 is 1. So you have a point at 0, 1. And then if I plug in 1, I get 1/2. So that would be 1, 1/2. And then if I plug in -1, I get an output of 2. So that would be -1, 2. So if you want to graph it, that's fine. So it would be horizontal asymptote at y equals 0. 0, 1 is right here. 1, 1/2 is right there. -1, 2 is right there. So it's going to look something like this. Oh, and then we got to figure out the domain and range. So the domain doesn't matter if it's increasing or decreasing, it's all real numbers. And the range, what do you think our range is going to be? So it's the smallest y value to the largest. So our smallest y value gets very close to 0. So we're going to do parentheses, not bracket, 0, and then it just shoots up to infinity. Okay, so that is your domain and range. Okay, let's move on. So this will be our last example. So graph the function, determine domain and range. So there's quite a few things that's going on. You have this 2, so I think that's a stretch or a shrink. I forget. But all you got to do is multiply 2 from the y value of your 3 coordinates. The x minus 2 is, so it's so that 2 represents a stretch or a shrink. I'm not sure. I forget all the rules, but it's okay. You can and then the x minus 2 means you have a horizontal shift of 2 units to the right. Also, is this going to be increasing or decreasing? Since the base is E, E is actually a number, it's like 2.7, so it's going to be a growth. And then the +4 represents a vertical shift of 4 units up. And what else does it mean? It's also your new horizontal asymptote. So you have a horizontal asymptote at y equals 4. Okay, so what I'm going to do is I'm going to pick 3 points from the parent family. So what is our parent family? A parent family is y equals e raised to the x, right? That would be our parent family. Now I'm going to pick 3 points. So if I plug in 0, I get an output of 1. If I plug in 1, what do I get? So he's like 2.7. So it'd be 1 comma e, which really is yeah, it's like 2.7. And then if I plug in -1, I get 1 over e. Okay. Okay. Then what I'm going to do is do the add-ons, right? So let's do this 2 here. What does that 2 do? It just I think it stretches shrinks, but if it's outside all you have to remember is you multiply the y coordinate by 2. So let's not use red, let's use blue. I can't see red real. Okay, so 0, 1. So wait, hold on. So now what we're graphing is y equals 2 raised to the x. I'm doing it 1 at a time. So all we got to do is multiply the y value by 2. So 0, this from the previous coordinates, 0, 1 will be 0, 2. 1, e will be 1, so it's 2 times e, which is it's about 5.4. And then -1, 1 over e is -1. And then it's 1 over e times 2, which is 0.74. Okay. So all I did was I picked from the previous coordinates, the y value. I just multiplied by 2. Okay. And then what we're going to do is let's use green. Y equals 2e to the x minus 2. So the x minus 2 represents a horizontal shift, so you're adding 2 to the x coordinates. So you start with the previous coordinate, not this one, but these ones. So 0, 2 will now be what? You just add 2 to the x, so that would be 2, 2, right? 1, 5.4 is going to be 3, 5.4. And then -1, 0.74, you add 2. So 2 plus -1 is 1, 0.74. Okay. And let's do another color. Let's use this brown. The +4. So the final graph. So it's 2e to the x minus 2 plus 4. So this +4 is a vertical shift, and all that means is you add 4 on the y coordinate. So 2, 2 would be 2, 6. 3, 5.4 will be 3, 5.4 plus 4 is 9.4. And 1, 0.74 will be 1, 4.74. Okay, there's your graph. I mean, those are your final coordinates, so let's start graphing. So we said I'm going to graph my asymptote first. So our asymptote is at y equals 4, so right here. I'll dash line a few months. And then just plot these 3 points and you will be good. So 2, 6 is right about here. 3 comma 9.4 is, here's 9, 9.4 would be there. And then 1 comma 4.74. You were about here, right? Okay, there's your graph. So that's how I did it. I list down everything we gotta figure out the domain and range. So the domain is still all real numbers. Doesn't matter if it's increasing or decreasing. And then the range is not all real numbers. What do you think the range is? So it's related. So our smallest y value gets very close to 4. So it's going to be parentheses 4. And then it just shoots up to infinity. Okay, so yeah, that's your graph. And that's how I graph it. I list everything I know, start with the parent family, do 3 points, and then just do the add-ons. Okay, go ahead and pause, or because you're gonna copy. But yeah, that wraps up for this section. The next video should be a quiz. Okay. Okay, thank you. Bye-bye.